This question is about adding resistors in parallel, and once you understand the basics of it, it's actually quite straightforward. So what happens if we had n resistors in parallel? So if you have one resistor in parallel, which sounds a bit silly, but one resistor in parallel, then you get R. If you add a resistor in parallel, you double the number of routes, you double the number of available paths, so the resistance halves. So you can show that using the equation 1 over R plus 1 over R, you get 2 over R, and then RT, you end up with a half. Then if I put 3 in, I've now got 3 paths, so it's 3 times as easy for the current to flow for the same voltage. So there's 1/3 of the resistance, and again I can do the 1 over RT is 1 over R plus 1 over R plus 1 over R, and keep going. And for this one, I'll end up with 3 over R. But hopefully you can see the number of resistors. You end up with N over R. So if I've got N, then 1 over RT ends up as being N over R. Now that, as a graph, which is what we're asked about, this idea of linearity is asking about a graph. Well, then the resistance against the number you've got, so the most it can be is R, then it falls to R over 2, then it will fall to R over 3, and it keeps falling and falling to R over 4, and you'll end up with this non-linear drop. So there, that's halfway, that's there, that's 1/3 of the way up, 1/5, and so on. So you get this, it's not continuous, it's discrete, but you'll get this effect. That's what the graph would look like. So from the answers available, decreases linearly as n increases, no. R decreases non-linearly as n increases, that's correct. So B is looking right. We'll check C and D. Increases linear as n, no, R doesn't increase and it's not linear. And then R increases non-linearly as n increases. Well, R is not increasing. As you increase the number of resistors, you're actually increasing the number of paths available, so the resistance falls.